Okay, again, so the next trend we're going to look at is reactivity of halogens, right? So right, that whole side of the periodic table is a non-metal. And they have the opposite trend in reactivity as the alkali metals. The reactivity decreases as you go down the group. Now, that's really, they will form, they'll form ionic compounds with metals. They'll form covalent compounds with nonmetals. We're not going to really worry about melting point at this point. We'll look at it more when we do Unit 4. But the melting points will increase as you go down the group. But reactivity will decrease as you go down the group. Right? In all cases for halogens, reacting for a halogen means, right? So let's put that in here. Because they're on that side of the periodic table, and they're that close to looking just like a noble gas, they just need one more electron to become much more stable. They will react by gaining electrons. All right? And that informs their trend. Right? Because alkali metals react by losing electrons, right, the easier it is to lose, the more reactive it is. Because halogens react by gaining electrons, the higher the electronegativity, the more reactive it is. So, and we're considering from I2, or from F2 just down to I2. We don't really consider AT. But F2 is the most reactive, and I2 would be the least reactive. Okay, there's a few, right, so, solid potassium would react with chlorine gas to form solid potassium chloride. Right, so that'd be a very violent reaction as they're both super reactive. And notice that also, so, potassium catches fire in water, making a purple flame. Chlorine gas, right? So that's a poisonous gas. And when they react together, they form this very stable potassium chloride, right? So you'll find that in table salt alternatives. And you can eat that easily, potassium chloride. Right, so sodium chloride, potassium chloride. You find this in a lot of different foods that are a salt substitute, potassium chloride. Question?
So is chlorine on its own poisonous because it's reactive and it'll destroy our lungs or whatever?
Yes. Yeah. Yeah. This is like super reactive and wants to gain electrons. It will rip electrons from anywhere it sees. Water, cells, the actual mechanism, yeah. Like nothing has ever adapted to chlorine. Right, so chlorine as a disinfectant, chlorine as something that kills microbial life, there is no adaptation to that. Okay. Okay, so this can be a little bit tricky. This idea of halogens displacing other halogens. So if you have chlorine, right? So you can actually put so chlorine gas. If you bubble that through water, you actually get these diatomic chlorine aqueous ions. And whatever is more reactive, right, will take the electron. Right? So in this case, if you have chlorine with bromine ions, it will produce chlorine ions and bromine, like diatomic bromine. And then if you have chlorine with fluorine ions, you will get no reaction. Okay, so chlorine, like diatomic chlorine with fluorine ions, no reaction. The fluorine has its electron, it's not giving it up. Right? It is the most electronegative element, it grabbed it, it's super stable. Right? So as ions, the halogens are very stable. As diatomic compounds, they are very reactive. Right? They're sharing electrons, but they would rather have an electron on its own. Right? So as diatomic, they're sharing, but they would they're at much lower energy and much more stable once they have an electron. Okay, so all halogens react by gaining electrons, right? So if you reacted sodium with fluorine, chlorine, bromine, iodine, right, you get sodium fluoride, sodium chloride, sodium bromide, sodium iodide. And again, these are all super reactive halogens, a super reactive metal, and then very stable compounds. Right, so sodium fluoride, right? That's in your toothpaste. If you use fluoride toothpaste, and you should if you want to protect your cavities, protect yourself from cavities. Right? So super reactive, very stable. Put that on your French fries. right? And these super reactive halogens are actually used as, disinfectants. Chlorine is used, to make chlorine bleach that eventually is a disinfectant. Bromine is used to disinfect hot tubs, right? Iodine is used as a disinfectant for skin, right? So you might get that iodine solution. Yes,
So like, how does it not mess up your skin then? If you like.
it does a little bit, but that's why they use iodine because it's the least reactive, right? They wouldn't use fluorine because, well, it'd be a gas and you would die.
So like, it's strong enough to kill the bacteria. But
Strong enough to kill bacteria, but not you, right? Probably too strong for your skin, right? Chlorine also exists as a gas. And then bromine is also probably a little too aggressive for your skin, right? So, but you can, if you have it in a certain dilution, you can sit in a warm tub, and like hot tubs have chlorine in it, or bromine usually. And a lot of pools have chlorine in them, right? So, if it's diluted, you can have chlorine. There's chlorine in our tap water too. Okay, so the higher the electronegativity, right, the more reactive. Okay, I think we'll pause there. I'm going to collect the tests. I'll leave this up. Copy that down. I'll just pause.